everybody, within the whole universe, hopped off this fine Irishman who makes all of them on experience, and today we're gonna dive into the outline of machine learning. It is about AI, ML, and NDL, which just means artificial intelligence, machine learning, neural networks, deep learning, and also we will talk about autoencoders, variational autoencoders, sparse autoencoders, denoising autoencoders, LSTM, long short-term memory perceptrons, and deep neural networks, and recurrent neural networks, and convolutional neural networks, and deep Boltzmann machine, and restricted Boltzmann machine, and also different types of Kahana networks, and also self-organizing maps, and features of this nature. Yes, I'm preparing for the PhD, actually, in relation to this aspirantura, and also we'll dive into the list that I found on internet. It's outline of machine learning from Wikipedia, and how will we prepare ourselves to join to university, actually, to the next after master's degree program. How will I do this? I will read. When we read, actually, we learn a little bit of it, because we dive into this and we kind of do comprehension, we do memorizing, we see some patterns. Actually, what do we do? While we are studying something, we actually recognize some patterns, and the next time when we see this, we will be kind of faster in approaching them, in seeing them, and also doing something with them, and creating, building, making, constructing, and developing, and initializing, and also different types of words that are synonyms of create or build or make, we can do when we see them in the next time. Okay, let's dive into this. I hope that you understand that the more you learn, the better you are, and you can learn it from different types of deepness, because you can learn you can go to, for example, predictive analysis, then you can read about it, and also you can read something more about words inside of it. Actually, what do we do right now? We are learning kind of outline, the surface maybe level of outline of machine learning. Not surface, but actually when we say some words, we learn more about the word, because maybe we have some inner knowledge about what we read actually. I hope that you understand. Maybe not. Okay, but let's dive into it. The more we learn, the better we are. Okay, what type of thing is machine learning? An academic discipline, a branch of science, an applied science, a subfield of computer science, a branch of artificial intelligence, a subfield of soft computing, application of statistics. Okay, branches of machine learning. Subfields of machine learning. Computational learning theory, studying the design and analysis of machine learning algorithms. Grammar induction, meta-learning. Cross-disciplinary fields involving machine learning. Adversarial machine learning, predictive analysis, quantum machine learning, robot learning, developmental robotics. Applications of machine learning. Applications of machine learning, bioinformatics, biomedical informatics, computer vision, customer relationship management, CRM, data mining, earth sciences, email filtering, inverted pendulum, balance and equilibrium systems, natural language processing, NLP, automatic summarization, automatic taxonomy construction, dialogue systems, grammar checker, language recognition, handwriting recognition, optical character recognition, speech recognition, machine translation, question answering, speech synthesis, text mining, term frequency, inverse document frequency, TF, IDF, text simplification, pattern recognition. And by the way, guys, for you it is the English listening practice. Yes, it is what it is. Yes, for everybody of us has the purpose. For example, you have your purpose to learn English, and I have purpose to learn English, and also improve my English and practice my English, and also to learn more and practice more of the terms inside of the machine learning. Okay, as the text term frequency, inverse document frequency, TF, IDF, text simplification, pattern recognition, facial recognition system, handwriting recognition, image recognition, optical character recognition, speech recognition, recommendation system, collaborative filtering, content-based filtering, hybrid recommender systems, collaborative and content-based filtering, search engine optimization, social engineering, machine learning hardware, graphics processing unit, tensor processing unit, vision processing unit, machine learning tools, comparison of deep learning software, machine learning frameworks, proprietary proprietary machine learning frameworks, Amazon Machine Learning, Microsoft Azure Machine Learning Studio, Distbelief replaced by TensorFlow. Open source machine learning frameworks, Apache Singa, Apache MXNet, Caffe, PyTorch, MLPack, TensorFlow, Torch, CNTK, Accord.NET, JAX. Machine learning libraries, Deep Learning 4j, Theano, Scikit-learn, Keras. Machine learning algorithms, Almeida, Pineda, recurrent backpropagation, Alopex, ALOPEX, backpropagation, Bootstrap aggregating, CN2 algorithm, constructing skill trees, DNA Chengox, need to check how to pronounce correct, DNA Chengox model, diffusion map, dominance-based rough set approach, dynamic time warping, error-driven learning, evolutionary multimodal optimization, expectation maximization algorithm, FastICA, forward-backward algorithm, GenRec, genetic algorithm for rule set production, growing self-organizing map, hyperbasic function network, iDistance, k-nearest neighbors algorithm, kernel methods for vector output, kernel principal component analysis, Leabra, LEABRA, Linde-Buzzo-Gray algorithm, local outlier factor, logic learning machine, logic boost, manifold alignment, Markov chain Monte Carlo, MCMC, minimum redundancy feature selection, mixture of experts, multiple kernel learning, non-negative matrix factorization, online machine learning, out-of-back error, prefrontal cortex basal ganglia working memory, PVLV, Q-learning, quadratic and constraint binary optimization, query level feature, quick prop, radial basis function network, randomized weighted majority algorithm, reinforcement learning, repeated incremental pruning to produce error reduction, RIPPER, RPROP, rule-based machine learning, skill chaining, sparse PCA, state action reward state action, stochastic gradient descent, structured KNN, T-distributed stochastic neighbor embedding, temporal difference learning, wake sleep algorithm, weighted majority algorithm, machine learning methods, instance-based algorithm, k-nearest neighbor algorithm, KNN, learning vector quantization, LVQ, self-organizing map, SOM, regression analysis, logistic regression, ordinary least squares regression, OLSR, linear regression, stepwise regression, multivariate adaptive regression splines, MARS, regularization algorithm, rich regression, least absolute shrinkage and selection operator, LASSO, elastic net, least angle regression, LARS, classifiers, probabilistic classifier, naive bayes classifier, binary classifier, linear classifier, hierarchical classifier, dimensionality reduction, canonical correlation analysis, CCA, factor analysis, feature extraction, feature selection, independent component analysis, ICA, linear discriminant analysis, LDA, multidimensional scaling, MDS, non-negative matrix factorization, NMF, partial least squares regression, PLSR, principal component analysis, PCA, principal component regression, PCR, projection pursuit, summon mapping, T-distributed stochastic neighbor embedding, TSNE, Ansible learning, ADA boost, boosting, bootstrap aggregating, bagging, Ansible learning, Ansible averaging, process of creating multiple models and combining them to produce desired output as opposed to creating just one model. Frequently an Ansible of models performs better than any individual model because the various errors of the models average out. Gradient boosted decision tree, GBDT, gradient boosted machine, GBM, random forest, stack generalization blending, meta learning, inductive bias, metadata, reinforcement learning, Q learning, state action rewards state action, SARSA, temporal difference learning, TD, learning automata, supervised learning, AODE, artificial neural network, association rule learning algorithms, a priori algorithm, ECLAT algorithm, case-based reasoning, Gaussian process regression, expression programming, group method of data handling, GMDH, inductive logic programming, instance-based learning, lazy learning, learning automata, learning vector quantization, logistic model tree, minimum message length, decision trees, decision graphs, etc., nearest neighbor algorithm, analogical modeling, probably approximated correct learning, PAC learning, repel down rules, and knowledge acquisition methodology, symbolic machine learning algorithms, support vector machines, random forest, ensembles of classifiers, bootstrap aggregating, bagging, boosting, meta algorithm, ordinal classification, informal fuzzy network, IFN, conditional random field, ANOVA, ANOVA, quadratic classifier, k-nearest neighbor, boosting, SPRINT, sprint, Bayesian network, naive Bayes, hidden Markov models, hierarchical hidden Markov model, Bayesian statistics, Bayesian knowledge base, naive Bayes, Gaussian naive Bayes, multinomial naive Bayes, averaged one dependence estimators, AODE, Bayesian belief network, Bayesian network, BBN, AODE, decision tree algorithms, decision tree algorithm, decision tree classification and regression tree, CART, iterative dichotomizer, 3, ID3, C4.5 algorithm, ID3, iterative dichotomizer, okay, C5.0 algorithm, chi-squared automatic iteration detection. How is it written actually? CHAID. I'm really interested in. Maybe we'll find something. Oh no, I didn't found it. Okay, but okay, chi-squared distribution. Okay. It is chi. It is written this way. I always was kind of thinking about what does it mean this letter. Actually, it is kind of X, but actually it is chi. Okay, chi. Okay. And decision stamp, conditional decision tree, ID3 algorithm, random forest. Actually, we have ID3 here and ID3 here. Okay, random forest, SLIQ, and ID3 algorithm. Okay, and it is actually the same link to them. SLIQ, linear classifier, Fisher's linear discriminant, linear regression, logistic regression, multinomial logistic regression, naive Bayes classifier, perceptron, support vector machine. Unsupervised learning, expectation maximization algorithm, vector quantization, generative topographic map, information bottleneck method, artificial neural network, feed-forward neural network, extreme learning machine, convolutional neural network, recurrent neural network, long short-term memory, LSTM, logic learning machine, self-organizing map, association rule learning, a priori algorithm, ECLAT algorithm, FP, growth algorithm, hierarchical clustering, single linkage clustering, conceptual clustering, cluster analysis, BIRCH, DBSCAN, expectation maximization, EM, fuzzy clustering, hierarchical clustering, k-means clustering, k-medians, mean shift, optics algorithm, OPTICS algorithm. Anomaly detection, K nearest neighbors algorithm, KNN, local outlier factor. Semi-supervised learning, active learning, special case of semi-supervised learning in which a learning algorithm is able to interactively query the user or some other information source to obtain the desired outputs at new data points. Generative models, low density separation, graph-based methods, co-training, transduction, kind of community. Okay, deep learning, connected, deep learning, deep belief networks, deep Boltzmann machines, deep convolutional neural networks, deep recurrent neural networks, hierarchical temporal memory, generative adversarial networks, deep Boltzmann machine, stacked autoencoders, other machine learning methods and problems, anomaly detection, association rules, bias variance dilemma, classification, multi-level classification, clustering, data pre-processing, empirical risk minimization, feature engineering, feature learning to rank, OCAM learning, online machine learning, PAC learning, regression, reinforcement learning, semi-supervised learning, statistical learning, structured prediction, graphical models, Bayesian network, conditional random field, CRF, hidden Markov model, HMM, unsupervised learning, VC theory, machine learning research, list of artificial intelligence project, list of data sets for machine learning research, history of machine learning, timeline of machine learning projects, projects, DeepMind, Google Brain, OpenAI, machine learning organizations, knowledge engineering, and machine learning group, machine learning conferences and workshops, artificial intelligence and security, AISec, co-located workshop with CCS, conference on neural information processing systems, and IPS, ECML, PKDD, International Conference on Machine Learning, ICML, ML for all, Machine Learning for all, machine learning publications, books on machine learning, books about machine learning journals, machine learning, Journal of Machine Learning Research, JMLR, Neural Computation. Persons influential in machine learning: Alberto Broggi, Andrei Knyazov, Andrew McCallum, Andrew Ng, Anurag Jain, Armin B. Kremers, Ayanna Howard, Barney Pell, Ben Goertzel, Ben Taskar, Bernard Scholkopf, Brian D. Ripley, Christopher G. Atkinson. Maybe I will make mistakes, but everything is fine. Okay. Corina Cortes, Demis Hassabis, Douglas Lennart, Eric Singh, Ernst Dickmans, Geoffrey Hinton, co-inventor of the backpropagation and constructive divergence training algorithms, Hans-Peter Kriegel, Hartmut Neven, and Heikki Manila, Ian Goodfellow, father of generative and adversarial networks, Jacek M. Zurada, Jamie Carbonelli, Jeremy Slovak, Jeremy H. Friedman, John D. Lefferty, John Platt invented SMO and Platt scaling, Julie Beth Lovins, Jürgen Schmid Huber, Carl Steinberg, Katya Sikara, Leo Brayman invented bagging and random forest, Brayman maybe, Lisa Gitour, Luca Maria Gambardella, Leon Boteau, Marcus Cutter, Mariar Mori, Michael Collins, Michael L. Jordan, Michael I. Jordan, Michael L. Littman, Nando de Freitas, Ofer Deckel, Oren Atzioni, Pedro Dominguez, Peter Flesch, Pierre Baldi, Pushmit Kochli, Ray Kurzweil, Rate Honey, Ross Quinlan, Salvatore J. Stolfo, Sebastian Thrun, Selmer Brinksjort, Sepp Hochreiter, Sean Leck, Steven Magleton, Steve Omohundro, Tom M. Mitchell, Trevor Hasty, Vasant Onavar, Vladimir Vapnik, co-inventor of the CVM and VC theory, Jan LeCun, invented convolutional neural networks, Yasuo Matsuyama, Yoshio Bengio, Zobin Kahramani. See also outline of artificial intelligence, outline of computer vision, outline of robotics, accuracy paradox, action model learning, activation function, activity recognition, add a line, ALINE, adaptive neural fuzzy inference system, adaptive resonance theory, additive smoothing, adjusted mutual information, AIVA, AIXI, Alchemy API, AlexNet, algorithm selection, algorithmic inference, algorithmic learning theory, AlphaGo 0, alternative decision tree, apprenticeship learning, causal Markov condition, competitive learning, concept learning, decision tree learning, differentiable programming, distribution learning theory, eager learning, end-to-end reinforcement learning, error tolerance, PAC learning, explanation-based learning, feature, GLOVE, GLOVE, hyperparameter, IBM Machine Learning Hub, inferential theory of learning, learning automata, learning classifier system, learning rule, learning with errors, M theory, learning framework, machine learning control, machine learning in bioinformatics, margin, Markov chain geostatistics, Markov chain Monte Carlo MCMC, Markov information source, Markov logic network, Markov model, Markov random field, Markovian discrimination, maximum entropy Markov model, multi-arm bandit, multitask learning, multilinear subspace learning, multimodal learning, multiple instance learning, never-ending language learning, offline learning, parity learning, population-based incremental learning. By the way, I want to Google what is it. And predictive learning, preference learning, proactive learning, proximal gradient methods for learning, semantic analysis, similarity learning, sparse dictionary learning, stability learning theory, stability in parentheses learning theory, statistical learning theory, statistical rational learning, Tanagra, transfer learning, variable order Markov model, version-based learning, waffles, Weka, loss functional for classification, mean squared error MSE, mean squared prediction error MSPE, Taguchi loss function, low energy adaptive clustering hierarchy, other, Ane Otate and colony optimization algorithms, Anthony Lewandowski, anti-unification computer science, Apache Flume, Apache Gigaf, Apache Maout, Apache Singa, Apache Spark, Apache System ML, Athelion software, Arabic speech corpus, archetypal analysis, Arthur Zimic, artificial ants, artificial bee colony algorithm, artificial development, artificial immune systems, astrostatistics, average to one dependence estimators, Becker-Wards models, balanced clustering, ball tree, base rate, BAT algorithm, Bohm-Welch algorithm, Bayesian hierarchical modeling, Bayesian interpretation of kernel regularization, Bayesian optimization, Bayesian structural time series, Bayes algorithm, behavioral clustering, Bernoulli scheme, bias variance trade-off, bi-clustering, big ML, binary classification, Bing predicts, bio-inspired computing, geography-based optimization, biplot, Bond's theorem, Bongard problem, Bradley-Terry model, Brown boost, Brown clustering, burst error. Let's check it out how much of it need to read more. I think here we can stop actually, because it is the links to the next features that we have, because see also actually means that here it is, see also, and here is others that we can read actually. We'll do this in the next time. I hope that you enjoyed the higher one, the upper that we read here. And thank you a lot for watching, Professor Daily. You're a nice guy or girl, and you learned some new stuff in machine learning and artificial intelligence, and about Markov chain Monte Carlo, and about different types of neural networks. You learned some names, maybe you heard them first time. Let me know in the comment section below if you heard them first time, and what are they that you learned first time, and what are the specific maybe neural networks that you maybe not learned first time, but you already known about them. Okay, see you next time, Professor Lely. You're a nice guy, oh boy, see ya. Oh girl.